Today we are going to look what is linear differential equations. Okay, so today we'll learn about this linear differential equations. So what is the definitions? What is the meaning of this linear in differential equations? So let's see something. So according to the definition, it said that it is a differential equations. What kind of equations is gonna be called as a linear? This kind of differential equation will be called as a linear if these two criteria is valid. Okay, like example number 1, first condition, the dependent variable, let's say, is a y. This dependent variables become a y, let's say, and is all derivative, the derivative of this dependent variable y. Okay, dependent variable y, if this occur in the first degree, only first degree, they are not saying second degree, only first degree, right? This is the first condition. And the second condition is that there should not be any product of dependent variable, like example x square, got it, or maybe dy by dx whole square, or maybe between this derivative and the independent variable, there should not be any product. Okay, this is the when this kind of differential equations valid these two criteria. Okay, then we can call it as a what, linear differential equations. So let's see a example. Okay, this is the example. What is the first example? Yeah, the first example is that dy by dx equal to x plus sine x. So here let's see the criteria first. Yeah, we know there is a differential equation. Is it valid? Yes. So we're gonna check whether it's a linear differential equation or not. The first thing is that we need to check what is the differential, what is the dependent variable. Dependent variable is the y, got it, and all its derivative occurs in the first degree only. Yes, the degree is only 1, right? So that means this first examples valid for the linear differential equations, correct? This one is correct. What about the second? Let's see. How many derivative are there? Yes, we have derivative. Which one is the dependent variable? Y is the dependent variable, but the degree is 2. You know, according to the definition, they said all derivatives should be occur in the first degree only, right? But here in the second examples, it appears as a second degree. So that means this is not valid. So one is valid, second is not valid. Okay, let's see the third example. Derivative of u. U is the dependent variable. Okay, so u is the dependent variable. So when there is a occur of the derivative of u, second derivative of u plus second derivative of u with respect to y, another one is the with respect to x, and c. Is there any second degree? No, only 1 degree. Okay, here also 1, here also 1, here also 1. I'm not talking about the order. Order can be 2, but the degree is 1. The degree is 1. The degree is only 1. So that means the first criteria also valid. Second criteria also valid. Got it? Yeah. First one is correct. 2 is wrong. Third one is correct. Means the first and the third is the linear differential equations. What about for example? What about this for example? D square y by dx square plus y dy by dx plus 5x plus sine x. So let's see. This one is derivative, highest derivative. Yes, this is the highest derivative. But what is the degree? The degree is 1. So first criteria is correct. Correct. So let's see the second criteria. It said that no product of dependent variable or derivative occurs. But here there's a like product of derivative and the product of dependent variable is there. So that means this is not a linear differential equation because the second criteria is not valid, because there's a product of y and the dy by x. What is it means? The product of dependent variable and the derivatives. So second criteria is not valid here. So that means this is not a linear differential equations. So what about the third example? So this one is the highest derivative. Yes, this one is the highest derivative. It's only 1. The first criteria is correct. According to the definition, first criteria is correct. First criteria is correct. But second criteria, it said that no product of dependent variable, and derivative occurs. See, there's a product y into y. There's a product of dependent variables, so this is not valid. Means the second criteria is not valid in this equation. So this is also not a differential. It's a differential equation, but this is not a linear differential equations. So only 1 and the 3. Only 1 and the 3 is correct, but remaining 2, 4, 5. Why? Because here degree is 2, here the product is there, here why? There's a product is there. So this 2, 4, 5 is not a linear differential equations. Only 1 and 3 is correct. 2, 4, 5. Why? Because here the degree is 2, so not valid. So here the product is there, means the second criteria of the definition is not valid. Here also, here y square means there's a product, so second criteria is not valid. So that's why this 2, 4, 5 is not a linear differential equation. Now you understand, right? What is the meaning of this linear differential equations? Correct? So let's see something again. Linear differential equation, and differential equation is said to be linear if the dependent variable y and all its derivative occurs in the first degree only. Correct? And there should not be no product. They said no product of dependent variable or derivative occurs. Understand? This is the first definition. So what about the non-linear differential equations? So you can conclude very easily. So if any of this criteria is valid, means when we check any differential equations, okay, when we see any differential equations, when we check all these criteria and all these criteria is not valid, then we can say as a non-linear differential equations. Any of the criteria is not valid, we can say non-linear differential equations. So that is the opposite. That is the difference between linear differential equation and the non-linear differential equation. But why we are learning these linear differential equations? Is because we want to find out the solutions. There's something called as solutions. Okay, so let me write down here properly. There's something called solution of a differential equation. Something called as a solution of a differential equations. What is the meaning? What is the meaning of this? So any relation between the dependent variable and the independent variable. What is that? Any relation between the dependent variable and the independent variable, which when we substituted in the differential equations, reduce, means the differential equation is reduced to what? Reduce it to a identity, is called a solutions, or we can say integral, or we can say primitive of the differential equation. Understand? So let's see the definition again. What is the solution of a differential equations? It said that any relation between the dependent variable and the independent variable, which we substituted the differential equation, reduce it into a identity, is called solutions. Okay, integral, or maybe we can call as a solution, or maybe integral, or maybe primitive of the differential equations. So I'll give you an example. Let's say y equal to c e to the power x is a solution of the differential equations of differential equation. Which equation? Sorry, equation of dy by dx equal to 2y. This is the first equations. Why this becomes a solution for this? So when we integrate this, what we got this. When we do the integration, we got this. So why is said that it's the integral of this solution. You understand? So this is the example. Okay, so this is the first definition, and we have also general solution. You also have general solution. So what do you mean by general solutions? General solution. What do you mean by this? General solutions. Okay, so let's see. It is a solution of our differential equations. In which the number of a arbitrary constant is equal to the order of the differential equations. So what do you mean by this? Let's see the definition again. It is a solution. Okay, this generation solution is a solution of a differential equation in which the number of the arbitrary constant, here becomes a arbitrary constant, is equal to the order of the differential equation. Example, let's say there will be an order of a differential equation, right? What is the order of this equations? It's 2, and it should be equal to with this arbitrary constant. Okay, should be equal to with the number of arbitrary constant. So there might be lots of arbitrary constant. There will be a number, right? Number of the arbitrary constant in the equations, in this differential equation. It should be matching with the order of the differential equation. So I'll give an example. Let's say y equal to c e to the power x is general equations of the differential equations. Which equation? dy by dx equal to 2y. Because why? The arbitrary constant is equal to the order of the differential equation, right? Differential equations means here we have only one arbitrary constant, and what is the order of this? It's only 1. The order of this differential equation is only 1, right? It's the only first derivative, right? So that means order is 1. So when we get a solution, this is the solution, right? This is the solution. When we got the solutions, the arbitrary constant is only 1. But there is not any 2 arbitrary constant. It's only 1 constant. That's why it called as a general solution. This called as general solution. Okay, so let's see another solution also. Let's see another solution. This is the called particular solution. We call it a particular solution. Why we say it's particular solution? Okay, so let's see the definition first. A solution often by giving particular values, to arbitrary constant, in the general solution. general solution is called what? It's called particular solution or particular integral. Like example, let's say I'll give an example. So let's see the definition first before we move to the examples. It said that any solutions, yes, obviously they will find a solution, obviously. So when they find a solution, it should be often by giving a particular values, okay, to the arbitrary constant. Like example, in the previous example here, we just say only C. This is an arbitrary constant, but there's no any particular value for this, right? But if the solution is given with the particular values, especially to the arbitrary constant in a general solution, it should be like this particular solution should be a general solution. Yes or no? You understand, right? We have discussed what is general solutions. When the order of the differential equations is equal to the number of the arbitrary constant, right? So it said that this particular solution is a general solution. So this general solution should be found when there's a given particular values, especially to the arbitrary constant. That is called particular solution. So I'll give you examples so that we can understand properly. Example, like let's say, like in the above example, okay, that I've given in the above example. What about if we taking C, the value of this C is equal to 1, then the answer will be what? Y equal to e to the power 2x is a particular solution. Of dy by dx equal to 2y. Now you understand or not? Right? Why? Because here before there was a C, but this C changed to 1 because we already take, because the particular value already given to the arbitrary constant. So how many arbitrary constants are there? Yes, we have only one. Yes, this particular solution also general solution. What kind of general solution? When the arbitrary constant like becomes a particular values. Here, this solutions become a particular solution. Now you understand, right? Because the arbitrary constants change to particular value. Got it? Okay. So there is another one more solution. What is this called? Singular solution. Okay. So what do you mean by singular solution? So yeah, before we give the definition, so let's see something again more. Okay. So till now we have understood what is the solution of a differential equation. Yes or no? Solution can be called as a integration or primitive of the differential equations. When this integrates, it becomes a solution. Okay. So what about the general solution? What is the meaning of general solutions? When the arbitrary constants is only, like, let's say, when the number of the arbitrary constant and the order of the derivatives become equal to, at that time we call this general solutions. And coming down, like we find out particular solutions. When within this general solution, if C is given a particular value, okay, here at that time we call as a particular solution. Now you got it? Okay. And what about the singular solution? What do you mean by this singular solution? And it should be a equations. It's way in equations. The function of this is called singular solutions. This equation is called a singular solution of the differential equations. The function of x, y, dy by dx, d square y, dx square, and here it goes on, d to the power n, dx to the power n equal to 0. So which one is the differential equation? Okay, this is the differential equation, this is the differential equations. So this equation will be called as a singular solution for this differential equation. How? So I'm not finishing the definition. If okay, if there is some criteria, if the equation, this equation, if this equation, okay, let me write down properly. Okay, if the given equations, this given equation is called as a solution, is the solution of the given differential equation. Yeah, obviously this given equation should be a what? Solution of the given equation. Yes, means what they're saying, that the equation should be singular, like when you are about to find out, okay, when you are about to find out this singular solution, we are going to say that this equation is the singular solution of this differential equation. So before we check anything, the first criteria we need to check is that whether this is a solution of this differential equation. I'm not saying that this is a singular solution. I'm saying first, this is a solution of this differential equation or not. That is the first thing we need to check. Okay, so and what is the second thing? The given equations, when it does not contain arbitrary constant. So what do you mean by this? Like example here in the above example here, in the above example, what say? We have arbitrary constant, right? Arbitrary constant is the 1. Like here also, what is the arbitrary constant here? Is C. But they are saying that in this singular solution, there should not be any arbitrary constant. Okay, don't worry, you will come with example, you'll understand properly more. So this is the second criteria. The first criteria is we should check whether it's a solution or not. And second, the solution should not contain arbitrary constant. Got it? And what is the second criteria? What is the second criteria? The given equations is not often by giving particular values to arbitrary constant. Okay, this one is very important. Okay, you need to see these things properly in the general solution. What do you mean by this? Like the given equations, first, what is the first? This should be a solution of the differential equations, and this equation should not contain arbitrary constant. Okay, and the third thing is that this equation should not be often by giving a particular values. So like this solution, they don't want to be involved with the particular value to the arbitrary constant. So for today, so we are going to end up this video here. So till now we have studied what is linear differential equation, what is non-linear differential equations, and we have seen different solutions. What is the solutions, what are the types, the general solutions are there, and we have particular solutions, we have this singular solution. So yeah, so like how to find out this singular solution, particular solutions, how to find out this general solution, or maybe the solution of any differential equations. Okay, so here I have to say it's a differential equations. So for this, like we'll be discussing more, we'll be solving more questions in the next video. For today, we'll be end up here. Okay, thank you.